All right, so as you may have guessed, we're going to start looking at lines and the equations of lines. So far we have two equations. We know that for any line that is vertical, we can write that equation as x equals whatever the value is where the line crosses the x-axis. So in this case, if x were 5, we'd be able to say the vertical line, x equals 5, is the line that has the ordered pair of x equals 5, y can be anything. If x equals 5, y equals 3, you would get, say, that point. X equals 5, y can be anything. No matter what y is, all the way down the length of the line, you are going to get 5 for x and whatever y is for y. So that's the equation of a vertical line. Also, the equation of a horizontal line, very similarly, is an equation where y equals whatever the value of the point where that line crosses the y-axis is. So in this case, say it's 3, then we have the line y equals 3. And just like before, we're looking at a place where a coordinate would be whatever x is, doesn't really matter, y is going to be 3. At this point, you would have y equals, x equals, for example, -4. Y equals 3. Up here, same thing, whatever x is, y is always going to be 3. So these are two equations of lines that you already know. Every other line that is not either vertical or horizontal has to have a slope. And the slope is defined as rise over run, always. So we're always looking at what happens on y over what happens on x. So any line that is not horizontal or vertical, and I'm just going to kind of sketch some random one in, say this one, any line that is not horizontal or vertical has not only a change in the x value, which, remember, a vertical line has no change in the x value, and a horizontal line has no change in the y value, but every other line is going to change both in x values as you choose different points along the edge of that or along that line, and it will also have changes in y values. And how we calculate those or mark those makes a difference for the equation of the line, which we'll begin to build later. All right, so you can see I've traded out my diagram for a nicer version, and this one has a few more labels on it, so let's talk about what those are. You'll see that we have a line drawn in which has 2 points marked on it, and the line is definitely not horizontal and definitely not vertical. The 2 points come into play when we try to describe how slanted is the line. You could describe this as a slanted line as opposed to straight across or straight up and down. But how slanted is the line? And every line, of course, is going to have a different kind of slant. If I were to put a line in like through here, that would be a different slant, or a line through here would be a different slant, or a line down here. There would be all different slants, and we need a way to describe that so that we can be accurate when we're working with graphs. So you'll remember that I referred to the slope as rise over run, and in the picture you're seeing a triangle drawn in. This would be a right triangle, a triangle drawn in to show the change in y and the change in x. In fact, these are the exact same things. The change in y, or the y change from one point to another, is the rise, and the x change is the run. Right? So change in x, change in y is the more mathy official way to say it, but rise over run is the easy way to remember it. So we're looking at traveling from one point to another point. How far did I have to rise to get to the second point, and how far did I have to run to get to the second point? And of course, far is distance or change in, and that's what we're looking at, is the change from the y-ordinate of the first point to the y-ordinate of the second point, and then the change in the x-ordinate from the first point, the x-ordinate to the second point. So using the picture, it's easy to find out what the slope of this line is. We're going to write the slope. by the way, the slope equals m. M is the letter that we use to mean slope. So m equals, well, let's go ahead and write rise over run, just so we're really clear what we're doing. So let's figure out what it took, or what the rise is from one point to another. Well, this first point on the left-hand side has a y ordinate of -1. And then to go to 3, I would have to rise 1, 2, 3, 4 units. Do the same thing on the x. We see that our x ordinate is at -2. And so I want to run 1, 2, 3, 4, 5, 6 units to get even with the x ordinate of the second point. Reduce this, and we can say that the slope of this line is equal to 2/3. That is the slope value. So one of the cool things about the slope of a line is that the slope of the line is the same no matter where you are on the line. It never changes. One line has one slope and it's always the same. So that means that I can use other points to calculate my slope. First, before I use other points, let's look at what happens if, instead of seeing what the difference is from the first point to the second point, what if we work in reverse order? What if I decide I want to find the slope, but I want to go from this point to this point, from here to here? Well, let's look. The rise, or the y ordinate for this first point, now our first point, is 3. So if I go to 3 on the y-axis, how far do I have to rise to get to the y ordinate of this second point? So I start here, and notice that when I rise, I'm actually rising downward. I'm going backward, or in the opposite direction. And in math, we show opposite with a negative. So my rise is 1, 2, 3, 4. So I had to go in the opposite direction 4 units. Oh, looking like maybe I'm going to have a different slope. But notice what happens with the x ordinate. If I start at 4 and move toward -2, I'm going to run backward as well in the opposite direction. And when I run backward, I go -6 units. I go the same distance, I just go in the opposite direction. 2 negatives makes a positive, so I have 4/6, and 4/6 reduces to 2/3. So I get the same slope regardless of whether I start at one point and move to the second point, or if I start at the second point and move in the opposite direction, then the triangle would look like this. So I still get a slope triangle, not as well drawn perhaps, but still I get a right angle that I can use to calculate the slope. All right, so let's recap a little bit. In talking about slope, we have decided that lines that are not horizontal and vertical have slopes which are a measure. Let me write all this out. They have a slope which has a variable m, and the slope is the ratio of the measure of the rise over run, or more mathily said, the change in y over the change in x. Okay, so we're not always going to have a graph in order to count, as I did here, my rise and my run. In fact, on this graph, if I chose any other points, I'd be guessing what their values are, partly because the graph doesn't have grid lines, so I can't see exact intersections of the various grid lines, and also because this graph on the area where the picture is has no other place that intersects at an integer. So if I looked at x equals 2, it comes somewhere before y equals 2, and I would only be guessing to see what that was. So it's often not even convenient to be able to not even convenient or possible to find the slope by calculating from a picture. But luckily we have a very famous formula for the calculations of a slope, and that is y2 minus y1 over x2 minus 1. So what does this mean? Well, if I look at my graph, they've given me 2 points from which I could use to calculate the slope. They're the same 2 points I used to count by just bouncing up and bouncing across, but let's use the same 2 points to calculate in this case. So I have 2 points. If I label them, if I say this is point 2 and this is point 1, now I can label my x and y for point 2 as x2, y2. It's very important that you get the right y with the right x and that you label them clearly before you start to calculate, because it's really easy to make mistakes on these slope calculations. And then for point 1, the same thing. I would have an x1 and a y1. Now you can see I have values x, y2, y1, x2, x1 that I can plug in. So let's do it and see what happens. So y2 goes with point 2 and it's 3, minus y1 goes with point 1 and it's -1, over x2 goes with point 2 and it's 4, minus x2 goes with point 2, it's -1. X1 goes with point 1, it's -2. So calculate 3 times the opposite, or 3 minus the opposite of 1 is the same thing as 3 plus 1. 4 minus the opposite of 2 is the same thing as 4 plus 2. So I get 3 plus 1 is 4 and 4 plus 2 is 6. I have the same value. Reduce to get 2/3 and I have the same final value as well. Let's try it in the opposite direction. This time I'm going to call the lower point point 2. So if this is point 2, now I'm going to call x2, y2. Notice all I did was change the labels. Same point, but now this is going to be my y2 and my x2. And in the other case, if I label this point 1, then x1, y1. Okay, let's do that formula. Write the formula again till you have it memorized. You should write it every single time. Equals, okay, y2 in this case is -1. -1 minus y1 is 3 over x2 is -2 minus x1 is 4. So -1 minus 3 minus 4, and -2 minus 4 is -6. 2 negatives makes a positive. I have 4 over 6, which equals 2/3. So when I bounce to count my rise and my run, I actually not only get the same end answer, but I get the exact same work along the way, right? -4 over -6, I started there with the bounce counting. So this is true for all lines. Okay, now, what did I just say that was a little bit confusing? I said this is true for all lines, even though when I started this whole lesson, I said we have vertical lines, we have vertical lines, we have horizontal lines, and then we have diagonal lines which have a slope. But I wonder, do horizontal and vertical lines have a slope? Well, let's see. Imagine this line right here, x equals 5. Pick 2 points on x equals 5. So let's say 5 and 3, and how about if I pick this point and say 5 and -2? Let's calculate the slope of that line, 5, 3, and 5, -2. This is getting cramped in here, isn't it? How about here? So m equals, well, let's come down here and just so we have more room. So I'm looking at the vertical line that has coordinates 5, 3, and 5, -2. Is that what I said? Yes. So let's use our formula. M equals y2 minus y1 over x2 minus x1. Let's decide which point is which. Let's call this P1 and call this P2. Well, if we've done that, then this has to be x1, y1, and this has to be x2, y2. Now just plug in my values. y2 is -2 minus y1 is 3 over x2 is 5 minus x1 is 5. So I get -2 minus 3 is -5 over 5 minus 5 is 0. What do we know about a fraction with 0 in the denominator? That fraction is undefined, which we write UDF. It's undefined to have a 0 in the denominator. It turns out that the slope of a vertical line is undefined. So whenever you do your calculations, if you get an undefined slope, you know you're talking about a vertical line. Well, what happens with a horizontal line? Maybe it's undefined as well. Well, let's see. Let's choose negative 4, 3, and how about, what does that look like? 4, 3 maybe? Okay, so let's do example 2. Negative 4, 3, and 4, 3. So we know that this is a horizontal line. Let's see what the slope is. M equals y2 minus y1 over x2 minus x1. If I call this point 1 and call this point 2, then this is x1, y1, x2, y2. A good idea in early days to write these little notations out so you don't make a mistake. And y2 is 3 minus y1 is 3 over x2 is 4 minus x1, which is negative 4. So I get 3 minus 3 is 0. 4 minus negative 4 is 4 plus 4. So I get 0 over 8. Well, it's not undefined because there's no problem with having 8 in the denominator. But if I cut a pizza into 8 equal pieces and eat none of it, I got none in my belly. So the slope in this case equals 0. And that's another truth about all horizontal lines. For all horizontal lines, the slope equals 0. So when you have a 0 slope, if you put this through the calculations and get 0, you know you're talking about a horizontal line. If you put your point through the calculations and you get an undefined slope, you know you're talking about a vertical line. All other lines, the slope will just come out of the calculation, and sometimes it'll be positive, sometimes it'll be negative, but it'll certainly not be 0 or undefined. One last thing before we go is to formalize a little bit more language. Notice I say that the slope has a variable of m, it's a rise over run, and that it's the change in y and the change over the change in x. Another way to say that, which is much more mathy, is to call the slope the rate of change. The rate of change. And what that means is we use this in real world situations, like when we're talking about word problems, where the slope of the line might define your income from an investment over time. And nobody says, when someone asks, how did you get rich? Nobody says, well, I earned a 43/59% over 5 years. That's crazy. We use a decimal in that case. And when we're doing that, I mean, we can call a rate of change a fraction, but when we're talking about a real world situation, we're often converting the fraction into some number over 1. So in this case, let's use this one for the example. If I were to take this fraction, convert it to a rate, which we've done before, just means divide by 3 in the denominator to get the denominator equal to 1. I also have to divide by 3 in the numerator. So 2 divided by 3, we know equals 0.66666. So we'll round up here at 2 decimal places over 1, or the rate of change is for every 1 unit, if this were a graph, for every 1 unit I go forward, my rise would be 0.67. I go forward 1 more, my rise would be 0.67. Forward 1 more, my rise would be 0.67. And I would get a graph with a rate of change of 0.67 every time I run 1. So my rise and my run still apply in rate of change. It's a slightly different language, and it usually is used to describe real world situations rather than purely arithmetic or algebraic situations. So a quick example of that would be if I were to quote a price to paint your house. And I said, if I take 4 hours, it's going to cost you $90. Oh, shouldn't say it that way, should I? Let's make a table. Hours and dollars. So 4 hours cost $90, and 6 hours would cost $135, and 8 hours would cost $180. What are my rates? At what rate do I charge you per hour to paint your house? Well, let's use the slope formula. M equals, let's choose a point. Well, I've already labeled P1 here and now P2 here. So that means that this is x1, y1, x2 would be 6, and y2 would be 135. I could have used this last point. I could have made this P1, but I just chose the two smallest numbers because, you know, small numbers are nicer. So y2 is 135. Take away y1, 90. x2 is 6. Take away x1 is 4. So 135 take away 90 is 45. Divided by 6 take away 4 is 2. So this is a situation where I would use a rate of change. I wouldn't say to you, I'll paint your house, but I'm going to charge you 45 halves dollars per hour. That's crazy. Nobody talks like that. But if I divide the denominator by 2 and divide the numerator by 2, then I get a unit rate where I can say I'm going to charge you some amount of money per every 1 hour, for every 1 hour. Pull out our little calculator, and I put in 45 divided by 2. I get 22.5. So I'm going to charge you $22.50 an hour to paint your house.